Hello guys and welcome back to Engineering Hack, where we try to solve engineering problems in a way that's hopefully easy to understand. Today we're actually tackling the law of cosines, which will be useful in some problems you're going to face whilst learning engineering, dynamics, statics, and the likes. Okay, so generally this is more on the statics front because obviously the dynamics your triangle is going to be changing at any instant. But on the statics, it's super useful to know the law of cosines. We're going to use it in a couple of problems. And in this video, all I'm going to do is derive it for you with you so that you know what it comes from. And you always can refer back to this video in case you forget. Also, I encourage you to derive it yourself because once you do, it is more, how can I say this? It's ingrained in your brain much easier than if you try to just memorize the equation. But the equation is this one here. And really, I got this screenshot from Google. If you Google law of cosines, you're going to get this and actually get a little calculator you can use. So how the hell do we come up with this law of cosines here? Well, we start with a triangle, okay, with obviously three sides, triangle, right? And then sides A, B, and C. And the idea here is what I'm going to do is I'm going to split this triangle like, let me make this a bit thinner, like this. I'm going to split it like this. I'm going to make a vertical line. It's not that vertical. As vertical as I can. A vertical line so that this makes a 90-degree angle here. 90-degree angle here, and that thus creates two right triangles, right? This is one right triangle here, and there is another right triangle here, okay? All you need to see is these two triangles. It's very similar. Remember that we did the same thing with the law of sines. If you haven't seen that video, you can check it out and put it here in the corner for you. You can check that one out if you want to. But we start exactly the same way as the law of sines, okay? Now, what this then creates is the following. Because I have two right triangles, I can know that this is the hypotenuse of one of the triangles, this is the hypotenuse of the other triangle, and thus I can write the equations for Pythagoras, right? The only thing I need to do before that is just give a name for this side here, which is not B, right? Because B is the whole thing. So I'm just going to call this one X for the sake of giving this a name, all right? So I can do Pythagoras, and for that, I'm going to say the hypotenuse squared equals x squared plus this side here, which I also don't have a name for. And I'm going to go ahead and call this h because it's height of this particular triangle. So I give it the name h. That's going to be easy for us to remember. This is going to be h squared. Okay. What about this other one? Well, for this other one, it's kind of the same thing, right? I have this one side, which is c. Do this in pink. So this is c right here. This obviously is h right here, so the hypotenuse is c. Well, the height is h, and then I have this side here, which is not quite b, right? But really, because we have b and x, we can write this as just b minus x, right? So that's b minus x. So this other one here is going to be c squared, which is the hypotenuse. Then h squared once again, plus that difference there, which is b minus x, and obviously that little side squared. Cool. So we're almost there. We just need one more. Obviously, we need the cosine one. And you can see that there's only one angle here. Angle gamma, and this angle here, we can do the cosine for this one. And we know that the cosine of gamma is just going to be the adjacent side divided by the hypotenuse. So the cosine of gamma equals the adjacent side, which is x, divided by a, which is hypotenuse. X divided by a. So note that I have now three equations. These three equations are just, fundamental equations of those triangles that I have there. I didn't do anything yet, right? And all I'm going to do for this law, to find this law, is relate these three equations, mix them up, substitute. That's all I'm going to do, literally, okay? So I'm going to go ahead and start with this one here, and I'm going to go and expand this here. And we know that this is going to be square root of first minus 2 times the first times the second, plus the square root of the second, right? So this here becomes c squared equals h squared plus b squared minus 2bx plus x squared. Okay, so I literally just did that. What up next? Next, I'm going to note that I have x squared here, and I also have x squared here. Okay, so if I solve for x squared, I can substitute it there. The other option is I have h2 squared. I can also do h2 squared if I want. So let's go ahead and do that. Let's solve for h2. So I'm going to leave h squared in one side of the equation. I'm just going to send this c to the side, or actually, never mind, I want to send these guys to the other side, right? It's going to be c squared minus b squared plus 2bx minus x squared. Okay, and now that I have this in respect to h squared, what I'm going to do is where I have this guy, I'm going to say, okay, so this is equal to this, right? So that means that A, let's rewrite this one here. Or where do I want to do that? Or if I want to grab, oops, sorry, the calculator there. I want to just rewrite this equation down here. So this, we'll call this 1, 2, and 3 so that this is not confusing. I'm just going to rewrite 1 here, right? And 1 says a squared equals x squared plus h squared. Okay, and then if I substitute, this is going to be x squared and then all that thing. So plus c squared minus b squared plus 2bx minus x squared. That's already great for us. Why? Because we have x squared positive minus x squared. Obviously, these two cancel each other out. And that's one thing for us to worry. One thing less for us to worry. A squared equals c squared minus b squared plus 2bx. Beautiful. Okay, next up. So now I have the cosine equation. I can use the cosine equation here because I can solve the cosine equation for x, right? So again, I'll take this one here, or equation number 3. I'm going to rewrite it over here. So cosine gamma equals x over hypotenuse, which is a. So therefore, x is simply a times cosine of gamma. If that's the case, then where I have x, I can substitute by a times the cosine of gamma. Okay, so I wish this was working. It's not for some reason. So this becomes a trick on a run it. I should say create more confusion, less confusion if I keep going down. So hopefully this is easier to follow along. Equals c squared minus b squared plus 2b, and then where I have x, I'm going to go ahead and put this, right? So that's going to be a times the cosine of gamma. And now the whole thing is I'm trying to solve for c, if you recall from the equation, okay? So now I'm just going to send things that are related to c to one side and solve for c. Okay? So in other words, I'm going to send this whole chunk here to the side. Everything that's subtracted is going to be so summing up. Everything that's summing up is going to be subtracted. So this is going to become c squared will be equal to a squared, just stays there, plus b squared plus 2b times a times the cosine of gamma. Negative, right? Sorry, negative. Okay, and now what I can do is I can go ahead and take the square root on both sides. So we're going to have c equals square root of a squared plus b squared minus 2ba or ab, keep it alphabetical. So I can count, and I think it looks pretty finished by now. I think this is it. I think this is all sides. Let's go ahead and check, obviously, make sure that we didn't do any mistakes. This looks correct from what I remember. So c equals the square root of a squared plus b squared minus 2ab cosine of gamma. C equals square root of a squared plus b squared minus 2ab cosine of gamma. So that does it for us. Why do we need this? You'll see in the very next problem we published. Sometimes you're not able to use a law of sines because you end up 3 equations, and the 3 equations each have one unknown. So whenever you get a case in which you have a triangle, obviously, and you have 2 sides, so let's keep the A, B nomenclature. We have this side A, you have the side B, and you have this angle here, theta. Whenever you have this setup, okay, you can, I think this is the best setup. This is the best setup. That's theta. Whenever you have this setup, you can use the law of cosines, and you cannot use the law of sines, because what's going to happen here is that you're going to relate, in this case here, angle alpha, so sine of alpha. The alpha is an unknown. Make sure I put all the unknowns here in green and all the knowns in black. Okay, so you're going to end up with sine of alpha over, alpha, what's this? Negative sine of alpha over A equals the sine of beta over B, which equals the sine of theta over C. So each of these equations, all the green ones are unknowns. Each of the equations has one unknown, so therefore you cannot solve this kind of situation with the law of sines. However, you can solve it with the law of cosines, because you're trying to solve for C, as we just learned. That's just going to be C will be equal to the square root of A squared, we have A, plus B squared, we have B, minus 2AB, we have both, times the cosine of, in this case, theta, right? So note that we have A, we have B, and we have theta. So we can solve for C and find this C here. And once we do find this C, then this is not an unknown anymore. This is a full number or equation. So therefore you can solve, once you have that, you can solve for angle beta and angle alpha, and you get all the parts of the triangle. Okay, so this was just a recap of cosines, where it comes from. Again, I encourage you to do it yourself. Just follow the steps. Make sure you understand it, because if you can derive it, it's going to be much easier for you to remember it afterwards. And after you have done this, and after you understand it, and after you don't have any more questions, what you can do is actually, if you just type into Google law of cosines, you get a little calculator which you can put the side of A, side of B, and angle of gamma, and it just gives you C. So after you've mastered this and you're comfortable, then you can just use a calculator to make your life easier. Okay, I hope this was useful. As per usual, if you have any questions, just leave them down below in the comment section. And if this video was somehow useful to you, consider giving this video a like. Thanks for watching, and we'll talk soon.